Before we go over Cauchy's residue theorem, I wanted to read you a quote from none other than Cauchy himself. So he published a memoir in 1814 which contained this residue theorem and then several computations of real integrals using complex integrals, which we're going to look at in the next chapter. And so this is what he said about his little paper that he published. He said, after having thought on this subject and brought together the diverse results mentioned above, I had the hope of establishing on a direct and rigorous analysis the passage from the real to the imaginary, and my research has led me to this memoir. And his memoir that he's talking about contained Cauchy's residue theorem. So let's look at it together. And if you've been able to follow along on this lecture series, this won't actually be a big surprise to you. So here we go. So we're going to have a simple closed contour with positive orientation. We're going to assume that F is analytic inside and on C, except at a finite number of singular points, which from the remark above, we know these singular points are actually isolated singularities. These live inside C. So then, here's a picture, by the way. Then, okay, the integral of f of z dz is just 2 pi I times the sum, k equals 1 to n, of the residue at z equals z sub k for f of z. So it's quite literally 2 pi I times the sum of the residues at each point. Now, we've tried in this class to avoid proofs and focus more on computation, but I can't help myself. It's really not a proof, it's a sketch of proof, and it's everything we've been talking about so far. So we know that the integral over c of f of z dz, we have a theorem, we talked about this theorem, that allows me to collapse the integral along c, to collapse it down as the sum of the integrals over each one of these singularities. And so I can write this integral as the sum of, let's say, k equals 1 to n. And I'm going to assume I have a little disk around each one of these. Let's call this this little curve C1 around Z1, C2 around Z2, so on and so forth. So I can write this as the sum of the integrals over ck of f of z dz. And then we just saw before that each of these integrals, right, if f of z, if f of z has is analytic except at these isolated singularities, then you know f is analytic on this deleted neighborhood around zk. So here, let's think about when k equals 1, f is analytic inside this disk except at this point z1. And so just like we showed before, in each case, you're going to get 2 pi I times the residue. So we'll pop the 2 pi I out, and we'll write this as 2 pi I times the sum of the residues, k equals 1 to n, and residue z equals z sub k f of z. So really wonderful theorem, and it's going to lead us to look at some more ways, some techniques that we can compute residues. But in the rest of this lecture series, I thought we would just work out some examples together.